In this problem, we want to synthesize this alcohol from this molecule. So the first thing that I'm going to be analyzing is how many carbons I have in the starting molecule and how many carbons I have in the target. So here I have 3 carbons, and here I have 1, 2, 3, 4, 5, 6. But now I can visualize this. I'm trying to think backwards. So retrosynthetic analysis. Thinking backward, these alcohol can come from the hydration of the following alkene. That is an alkene. If I hydrate that alkene, I can make that. Then we're figuring out the reagents. So I'm going to do an arrow. We're going to fill the blanks here. Now, in the alkene here, you can disconnect that into 2 fragments, and I can visualize that coming from a Wittig reaction, in which I can have 1 fragment being this aldehyde, and I can make this would actually, this compound, make the Wittig reagent to add here. So doing this backwards, Wittig reagent, remember we need to make the attack with phosphine. So let's do that. If I need to make a Wittig here, the first step is the nucleophilic attack by triphenylphosphine. So I'm going to do that. Well, that is a secondary alkyl halide. It's not the greatest for this. The reaction works better for primary alkyl halide because that's an SN2. So first I'm going to be making them after that attack. Essentially, that's a substitution reaction. By now, phosphorus has a positive charge. And let's remember that when we do Wittig, now we need a strong base. And that base is typically butyl lithium, which is a very strong base, is this. And lithium is simply the counter ion. What we're doing here is then removing an H, a hydrogen, that is acidic. So I'm going to be removing, here you have an H. And I'm going to be doing the acid-base reaction. So this base is going to remove that. And in doing so, I'll be making my reagent, which will have, now that I have removed the H, I'm going to have the electron pair. And now I'm going to have the phosphorus with a positive charge. And this has a resonance structure. Remember that phosphorus can have more than 8 electrons around because it is in that 3rd period of the periodic table. It's right under nitrogen. So now in doing that, I'm making the resonance structure so that we can see better what is that we will be inserting. So now the resonance structure is this pH 3. That. And what we're doing in the Wittig, let's remember that we will be inserting this where the oxygen was in the aldehyde or a ketone. I'm not doing the mechanism here. If you need more details on Wittig, I have several videos on that. You want to check that if you need it. So the next step will be now combining this Wittig region with that. So, and I'm doing that right here. So that Wittig that I'm just made is this. I'm using the resonance structure now. I'm combining these two to make this. Okay, now that I have the alkene, I need to go from the alkene to the alcohol. So what do we do here? We need to analyze whether that hydration happened Markovnikov or anti-Markovnikov. So here you have the alkene. You had added, let me write it. To get that alcohol, you need to add the H, add the more substituted in DOH, add the least substituted. That orientation is anti-Markovnikov. So I'm going to write that down. This needs to be anti-Markovnikov. And to do that, there is one condition that we use, and this is first I'm doing borane in THF. So hydroboration, and then we do oxidation. So we're going to use hydrogen peroxide and hydroxide. And here we need to remember that this reaction not only is anti-Markovnikov, but is syn addition, so it's stereo-specific on that. So if you have a chiral center, you want to specify how you're adding that. I didn't say that in my target, but for example, if you're doing OH here, then here you will have the age. I'm going to draw it for now like that. The age should be here, meaning that one of these should be dash. Because I need this two in same position, or you can have the following. So dash, dash, dash here, and now I'm adding the hydrogen need to be also on dash, meaning that now the metal is going to be here. So notice that this chiral center has inverted configuration. This chiral center, well, actually, this is not a chiral center. Metal, metal. So no, not a chiral center, but here you want to keep the syn orientation. The only chiral center has inverted configuration, so these are enantiomers. Enantiomers. Should have written that again. And I am. So enantiomers, the configuration of the chiral center is inverted. I wasn't given that there, but since I'm doing the anti-Markovnikov addition, we need to keep in mind that this is also a syn addition, stereo-specific.